Good morning, friends. Now, today we are going for the exercise 3. 1, 2, 3, 4 questions already done. Now, we are going for the question number 5, which is important question and it is like theoretical question. So that the matrix B dash AB is symmetric or skew symmetric. B dash AB is symmetric or skew symmetric as A is symmetric or skew symmetric. As A is symmetric for A is symmetric or skew symmetric. If A is symmetric matrix, that means we have to prove that B dash AB is symmetric matrix. Or A is skew symmetric matrix, then we have to prove that B dash AB will be skew symmetric matrix. This is the given condition. Therefore, we have to go with two cases. First one is if A is symmetric matrix. According to this statement, we have to calculate or we have to prove that B dash AB is symmetric matrix. And the second case will be if A is skew symmetric matrix, then we have to prove that B dash AB is skew symmetric matrix. Okay? Now I am going with case number 1. If A is symmetric matrix, what can you say about A if A is symmetric matrix? So we know that the property of symmetric matrix A dash equals to A, then A is symmetric matrix. Therefore, we can write that A is symmetric matrix. Therefore, A dash equals to A transpose equals to A. Now, we have to prove this matrix will be symmetric matrix. For proving that, we have to assume that this matrix as a simple other than small representation of this matrix will be C. I am considering the matrix C, which is equals to B dash AB. I am considering the matrix C, which is equals to B dash AB. Okay? It is for calculation method. But we have to prove that C dash equals to C. Then we can say that C is symmetric matrix. And what is C? C is B dash AB. Therefore, we can say that B dash AB is symmetric matrix. Therefore, we are going for the C dash. Now, C dash is equals to B dash AB whole dash. Now, the rule for two matrices will be AB whole dash equals to B dash into A dash. This is the property of transpose of matrix for two matrices. If three matrices are there, suppose A, B and C are there and whole dash or whole transpose is there, then we have to do it in reverse order. C dash, B dash, A dash as two matrices. It is similar to two matrices. It is in reverse order. Therefore, we are going with reverse order C dash, B dash, A dash. This is the property for three matrices of transpose of matrix. Now, therefore, we can say that B dash, A dash, B dash, whole dash. Now, we know that A is symmetric matrix. Therefore, A dash equals to A and B dash dash equals to B. This is also property. This is idempotent law. Now, B dash A into B. Now, see here, B dash A into B will be C. Therefore, we can say that C dash equals to C. Here, C dash equals to C. Therefore, we can say that C, which is equals to B dash AB, is a symmetric matrix. Clear? Now, going for the second case. Now, what is second case? If A is skew symmetric matrix. If A is skew symmetric matrix, then we can say that A dash or A transpose equals to minus A. This is the condition for skew symmetric matrix. Now we have already assumed that C equals to B dash A into B. We have to prove in the second case C is q-symmetric matrix. Therefore, we have to prove that C dash is equals to minus C. For this proving, we have considering C dash which is equals to B dash A into B whole dash. Now we know that the multiplication of three matrices in transpose, we have to write separate transpose in reverse order. Therefore, B dash A dash into B dash dash. Now B dash A dash is equals to minus A. Therefore, put the value of A dash minus A. B dash dash which is equals to B. Now, if minus is that, therefore it is the multiplication of matrix by scalar. What is which scalar number? Minus 1. If we multiply any matrix by any scalar, we can also take common from that matrix. Therefore, we can write minus sign here. Therefore, we can write minus sign here, minus B dash A into B. If we multiply minus A with B dash B, or if we multiply A with B dash B and then apply minus sign, it is similar to that. Therefore, we can write minus common from that, B dash A into B. Now see here, what is B dash AB? B dash AB equals to C. Therefore, C dash is equals to minus C. Here C dash equals to minus C. Therefore, we can say that C, which is equals to B dash AB, is skew-symmetric matrix. Okay. Now, going for the question number 7 of exercise 3. Question number 6 already given in the self-practice. Yeah, the similar question of related to question number 7 is question number 9. You have to do the question number 9 in self-practice. You have to calculate the question number 9. Please see this question carefully. In this question, for what value of x, the multiplication of these three matrices will equals to 0 matrix. Here O is 0 matrix. Now, the question is arise in our mind will be 0 matrix of which order is that? Okay? The 0 order matrix of which order is that? Therefore, we have to use calculation of multiplication of these three matrices. Okay? Now, for the calculation of these matrices, we can also use the rule A into BC equals to AB into C. This is associative rule. If we can multiply these two first, then multiply with this. Or you can multiply these two first and then multiply with this. I am going with this first, the multiplication of these two matrices, then going with this. Okay. Now, see what is the order of the matrices. I am considering this is matrix A of order 1 by 3, matrix B of order 3 by 3, and matrix C of order 3 by 1. First of all, I am doing this multiplication. I have skipped the multiplication of matrix A and B, which gives us the order of matrix will be 1 by 3. Okay, the calculation is possible because number of columns of matrix A and number of rows of matrix B, which are equal 3 and 3. Therefore, multiplication is possible, and the order of given obtained matrix AB will be 1 by 3. Now I am multiplying matrix C with AB. Therefore, this multiplication is also possible because number of columns of AB and number of rows of C, which are also equal 3 and 3, and the order of the obtained matrix ABC will be 1 by 1. That means number of rows 1, number of columns 1. That means only one element is there. Therefore, we have to take 0 matrix as 1 by 1 matrix. Okay, therefore we have to zero matrix as 1 by 1 matrix. Therefore we can write zero matrix is equals to only element 0 and 3. Okay, now and start with this. First of all, calculate this one. First row, first column, we obtain first row, first column 1, 1 is 1, plus 2, 2 is 4, 1 plus 4, 5, 5 plus 1, 6. Okay, now multiply this one. First row, second column, 2 plus 0 plus 0, answer will be 2. The third column, 0 plus 2 plus 2, answer will be 4, into matrix 0 to x, which is equals to 0 matrix, which is equals to 0 matrix. You have to write the similar question here. Okay, now multiply this one with this. We are obtaining 0 plus 2 2s are 4 plus 4x, 0 plus 4 plus 4x, we are getting 0 here. Okay, now compare by using the equality of matrices. By using equality of matrices, we can say that 4x plus 4, which is equals to 0. Therefore, value of x will be minus 1. You can similarly calculate the question number 9 in self practice. You have to do like this. Okay.